Hi, so I'm doing a summary of the first part of the lecture from Monday, April 6th. Unfortunately, I didn't hit record on the Zoom meeting until after we had kind of gotten started. So this is a quick review of whatever we had missed in the beginning. So first I talked about the test. I will keep it brief here. I sent everybody detailed comments. Hopefully you understand why you missed the things you missed. So in general for tests, if you have a question about your grade, which means you think I actually made an error, so you got something right when I marked it wrong, my comments don't make sense to you, you don't think I should have taken points off, or I said you did something wrong that you don't think you did, something along those lines, you need to email me or WhatsApp me by tonight, which is Monday, April 6th by midnight, and let me know that you have a question about your grade. Try and be as specific as you can. I think number 2, you took off too many points. I don't understand the comment on number 3, part A, whatever it is. And we don't have to fix it today, but you need to let me know today that you think there's an issue with your grade. And then we'll make an appointment to either chat by WhatsApp, by Zoom, or email back and forth so that I can explain to you how I made that grade, and or we will discover if there was in fact a mistake made. In terms of just going over the test, if you want to review it, which you all should, because the final is cumulative, I encourage you to go over it first on your own, look at the comments, try and fix it. You can also work with our embedded tutor, Fardot, or you can text or email me and we can kind of discuss it. And I'm happy to discuss that with you at any time. So you can do that now, you can do that in a week, you can do that right before the final when you're reviewing your test study for the final. That's fine. The tests are yours. In other words, I know they're out there. You don't have to try and be secretive with it. You can print out the copy and redo it for practice, discuss it with the tutor, discuss it with other friends to try and find out how to solve the problems. I don't post solutions because I think it's more beneficial for you to actually try and go back and correct them on your own, but I'm certainly happy to share what the right answers are and check your work and discuss it with you at any time. I also just I won't go over it as in depth as I did in the Zoom call, but just to reassure everyone, be easy on yourself, be nice to yourselves. There was a 2-week break before the test, which made it hard, and it was not a fun 2-week break. Probably took people some time to get a comfortable space, figure out how they're going to work. I encourage you to create some structure now that we're back in school so that you know when you're studying. Let the people that you're living with know when you're studying so that they can respect that time and give you, peace and quiet so that you can be focused. If you're struggling with that, struggling with how to organize yourself, or you're having some issues in your home situation, please let me know privately and I will do what I can to help you if it's either brainstorm ways to work around it or if you need access to resources. And then I did review again, everything is on Canvas, so make sure you have your settings set up to let you know when assignments are due. Look in the assignments, that's where I post what you to do every day, and the calendar. And then just a review of what's going on this week specifically. So today was the Zoom meeting, or you're watching it. If you're watching it, you'd be watching 2 videos, this video as well as the Zoom meeting, which was recorded halfway through. Tomorrow is going to be what's a flipped lesson. So in other words, open up assignments and there is a video for you to watch, some notes to read, and some activities to practice. Tomorrow there's nothing to submit, but I am expecting that you are spending the hour and 10 minutes learning material every day in addition to doing homework, just like in the regular setting. So the learning tomorrow is kind of independent learning, but I am expecting you to do it. I am available between 8 and 9:10 in addition to any office hours, any day where lessons are flipped, to interact with you real time live. So as you're watching the videos or reading the notes, you can WhatsApp me, email me, or ask for a Zoom conference to go over any questions you have real time in terms of understanding the lecture material. And then on Wednesday, it's the same sort of thing where it's flipped. And then on Thursday, we will do a Zoom lesson again. Tonight's homework is going to be to do section 15.1. And then tomorrow you will be attempting 15.2. I did get some feedback about due date, so I will make sure that the due dates are consistent with the policy since the beginning of the semester, which is I assign it one day, you have that day to do it and try it. The next day you can ask questions, and then it's due the following day. So I'm extending 14.7 to be due tomorrow. 15.1 I'm assigning tonight. You should have it done by tomorrow. If you had questions, you can ask me or ask our tutor, and then it should be done by Wednesday, and that pattern should continue. So I will double check that the dates are correct. Also, just a reminder about our tutor and our embedded tutor. She is available on WhatsApp, and I emailed her hours, and her hours are in the announcements on Canvas. She's also a student. Please be respectful of the hours she's working, so you can Zoom with her. It's an open Zoom meeting that's recurring, and the address is on the announcements. Anytime she has hours, if you post a question on WhatsApp for her, don't expect her to answer until it is her working hours. I don't think it's fair for her to have to be available 24/7. You can certainly ask the question if you want to make sure you don't forget, but just make sure that you know she's not going to be answering things until it's her hours. All right. Then I think the other thing that was missed on the Zoom before I started recording was the review of 14.7. So a specific question that was asked from Joey was this number 16.2 from 14.7, which you see on the screen here. So in 14.7, you started thinking about the second derivative. So just like in Calc 1, it's the rate of change of the rate of change. What's happening now on a surface is we have an infinite amount of directions to go again. But we're going to really focus on either going in the x direction or going in the y direction. So the second partial derivative with respect to x would be that I'm going here in the x direction, and I'm looking at what's happening to the rate of change of the partial derivative of x. So that means as the rate of change is getting bigger, these contours should be getting closer. If the rate of change was getting smaller, the contours would be getting further apart. Similarly, if I want the partial derivative with respect to y, the second partial with respect to y in the y direction. What the mixed partials would be, and I believe we discussed this in the Zoom meeting part that is recorded as well. Let's say I want the mixed partial of x with respect to y. I'm looking at what's happening to the contours in the x direction as I move up in the y direction. Just like in Calc 1, these second derivatives tell me about concavity. So what's interesting on a surface, however, is at one point I can have different concavities. Think of a saddle point. Depending which direction I move in, I might be concave up or concave down. So for that reason, we have these different kinds of second derivatives that give us different information. On this particular problem, this is really kind of a thinking about what does everything mean and putting everything together type of problem. We have 2 points. The 2 points are on the same contour. So here's kind of a diagram of what that might look like on the surface, which means they have the same z value. They have the same output. Then they tell me that here's a linear approximation at each point. Remember, this is a tangent plane. So here's one tangent plane that has this equation, a plus bx minus x1 plus c times y minus y1. And here's the other tangent plane. So what you need to realize here is that these coefficients, this is what I was writing down here. If you think about how you find equations of tangent planes, you're using the partial derivatives. So that means b would be the partial derivative of x at that point x1, y1. C is the partial derivative of y at that point. Moving down to the second equation, m is the partial derivative of x at the point x2, y2, and similarly n is the partial derivative of y at that point. So what they did was they gave us points P and Q, and they didn't tell us which one had coordinates x1, y1 and x2, y2, and we're supposed to figure that out from the hints. The hint is that B and C are both positive. So that means that this partial derivative with respect to x and the partial derivative with respect to y at the point x1, y1 have the same sign. They are both positive. How can I figure out which point that's going on at? I remember that the partial derivatives are the components of the gradient. When the gradient points in the direction of greatest change. They told me m is a minimum or a maximum, so the gradient is perpendicular to the contour, must be either pointing towards m or away from m. So at point Q, I see if it's pointing towards m, that means that both x and y components are going to be negative, so both partial derivatives would be negative. If it's pointing away, both partial derivatives would be positive. If point P, notice it's the opposite direction. If the gradient's pointing away from m, the partial with respect to x would be negative and the partial with respect to y positive. Pointing towards m, the partial with respect to x would be positive and the partial with respect to y would be negative. So at point P, the partial derivatives have opposite signs. At point Q, they have the same signs. So that means that this one, this tangent line with B and C, where they told me have the same signs, has to go with point Q. So x1, y1 is point Q. Since not only do B and C have the same signs, they're both positive, the gradient must be going like this away from M. The gradient points in the direction of greatest rate of change, which means M must be a minimum because the gradient is pointing away from it. So if x1, y1 is point Q, that's where we got here, that point P has to be x2, y2, and that M has to be a minimum because the gradient has both these partials being positive, pointing away from M. On the same note, that means that this tangent plane at the point x2, y2 goes with point P. The gradient has to be pointing away from M, so that means the partial with respect to x has to be negative, and the partial with respect to y is positive. The partial with respect to x here is represented by M, and the partial with respect to y is n. So that's why M is negative and n is positive. For part A, since we said they're on the same contour, that comes back to that. We talked about that earlier, but we didn't answer part A. They're on the same contour, so that means that the final output, right, the value of the point of tangency, if I input x1, y1, or I input x2, y2, the z value on the surface and on the tangent plane has to be the same. So A and K are the same. So to kind of sum up what we discussed here so that you can see it and pause, here is the solutions to that 14.762, kind of summed up a little bit nicer than my writing there. So P and Q are on the same curve, so A is equal to K. Here they talk about, again, that those coefficients represent the partial derivatives, and understanding that the partial derivatives are the components of the gradient, I can tell what the signs are, and in that way kind of unsolve their mystery here. And then after this, we got into the 15.1 notes, and at that point I did start recording the Zoom meeting, so you should go watch the rest of that at this time.